All right, so end of arm tooling, again, it's about as diverse as anything you'll go into a hardware store to pick up. Because they can do anything. All it takes is what? Huh? Well, you can do changeovers, but you have to be able to design the tool to do the job you want. You can put a forklift on these things. As long as the robot is big enough, it'll pick up just about anything. You can put welders, you can put paint sprayers, you can put cutting, grinding, whatever you want to do. These guys can do it. And the coolest thing is a lot of these newer ones are starting to become more flexible still because they have the ability to go from, oh, I don't need a screwdriver for this job, I need to go and pick up a wrench. And they're able to do it. Very clever programming. You know, that's where it always comes in of, well, they seem intelligent. Well, they're not. They're a computer, right? And while computers can have the seeming of intelligence, they cannot think for themselves. We're not to the robot revolution yet. And God, I hope AI does not get there. So some of the things we can put on this is a vacuum device. Does exactly what you don't think it does. So these things have suction cups on them. They are able to pick up things like windshields or something as light as paper, butcher paper, to go between pallet type or pallet stacks. You have magnetic devices. These typically are electromagnets, or permanent magnets are not something you really want to use because then you have to find a way to get it away from the permanent magnet, which if you've ever had two magnets stick together, however they sometimes get apart. So electromagnets are used quite frequently. Permanent magnets are getting there, but it's all to lift magnetic, well, I won't say magnetic parts, it's parts that have the ability to be magnetized too. There's a lot of metals that cannot be magnetized. Flexible pneumatic devices, you got fingers, mandrels, and all sorts of other things, but these use air to help lift something. It's using air pressure. Now, another thing you can use is hydraulics. Hydraulics are something you need when you've got to have, if you have very little space, but you need a whole lot of power. If you want to know how much power hydraulics have, look at the Grand Canyon. Solid rock that has been cut away by nothing but water. That is hydraulics. Able to cut through solid rock. Another interesting example of hydraulics, and this one is where they actually mix things into water, but you have water jet cutting. Now, I will go ahead and tell you the caveat to that is that it's not just water doing the cutting. They typically will add some sort of grit to it, like sand or something like that. They add that to the machine because that is what helps with the cutting process. So, yep. I'll have to take a look at it. So the device, so we call it the EOAT, end of arm tooling. Sometimes it's called the end effector. Basically, a lot of people try and call it a gripper. Now, is every tool a gripper? No, it's not. That's why it gets, but it's used so widely because it kind of got into mainstream terms. It's kind of like, why is a battery known as a battery and not a cell? Because everybody calls them batteries. So the function or purpose is to actually do the job the robot was designed for. So think about the tool at the end of the arm like your hand. Anything you do with this and the dexterity of your hand, these guys are able to do, as long as you create the right tool for it. If you do not have a hand at the end of your arm, the whole arm's kind of useless, right? It can't do anything. Because this is what does every job. I don't care if it's picking up a soda can, writing something, doing things in your day-to-day life, driving and everything else. All of it has to revolve around our what? Has to revolve around the hand, right? Without the hand, everything goes, right? That is the whole purpose behind an end-of-arm tool. The whole purpose is to manipulate and move and use the hand it's attached to. Because otherwise, what's the point? Right? Otherwise, what is the point? So tooling must be able to do what it's meant to do. Here you see it talking about gripping, holding, and releasing. However, that only applies to grippers. Or if you're having to pinch something together like a welder. That does not apply so much to something like a paint sprayer, right? Because a paint sprayer, all it's got to do is spray paint. It's not gripping or grabbing anything. The tooling can be, I'm going to have to rechange that whole sentence because I don't like the word optional sitting in front of that. But the tooling must be able to respond to signals indicating the presence of a part. That is completely optional, okay? I'll tell you why. It's a good idea to do something like that, but that does not mean it has to talk to the robot itself. A lot of the times you have go-betweens between the robot and its controller, or not its controller, the robot and the line it's attached to, or the equipment it's attached to, generally through PLCs. Now, PLCs will take the signal from sensors and send it back to the robot's controller saying, hey, this has been tripped, execute the program that goes with this. But it is not required. Yeah, I can say that. It's not completely required. Okay? Why do I say that? I say that because you can put these things on timers and know that, okay, so we have X amount of time between parts being put in. Does that make sense? So as long as I can keep a rhythm to X amount of parts, then my robot will never be out of step. Does that make sense? So if, let's say I have a bottle cap, a capping robot that puts caps on toothpaste. If I know how many toothpaste tubes I can do in an hour, I know how many pass in 1 minute, I can program the robot down to the millisecond on whenever it needs to come in and put that cap on. I don't need to have a sensor. Because sensors are great up until they're not. Sensors do have a tendency to break down over time. You have to have a lot of maintenance on them, and they can be quite expensive. If you've ever had to replace the tire sensor in your car, you know what I'm talking about. They're not cheap. So a lot of people, if they can get away without having to use something like that, they will, just to save a few bucks, right? Not to mention the program timing. But it does have an issue if you do not have something to sense the presence of that item, then you very well could end up with toothpaste tubes that have no caps. Why? Because the robot got out of sync with the line. It happens, but it's also a lot about where everything is and how it's operating. Okay? The tooling must be as lightweight as possible to satisfy as, let me put it this way. You don't want your tool being overweight, because the heavier your tool is, the more payload spec it takes. So what do I mean by that? I mean that if your robot, let me put it into you in different terms. How much can all of y'all bench press? Somewhere around, what, 50 pounds-ish? Somewhere around in there? Now, what if I start adding weight to that? That's going to start getting rid of your payload capacity, yeah? Because there's only so much your arms can lift at that time. Now, we have the ability that we can go out and get stronger. We can go to training, 5 days a week and work to get higher muscle mass and everything else so that we can lift more. These guys can't. They have what's called a payload spec. Now, the payload spec revolves completely around how much can that robot pick up and move, right? What is its total capacity? If you have the robot picking things up and moving it, you do not want a tool that's too heavy, because then you do what? You start exceeding that payload, right? But you want it heavy enough, you want it to be robust enough it can do the job. Does that make sense? Now, the end of arm tool does not come standard with a robot. Does that make sense? The robot manufacturers, KUKA, Fanuc, Motoman, all of these guys, next to none of them have tools that actually come on the robot. All that comes on a robot, which I had one of them, but so all that comes on a robot is it has a flat face plate that you can mount to, but it is not going to be a standard tool. Does that make sense? It's not like you're going out and buying a impact driver and it comes with a few bits in it. No, this is, you go out buy that impact driver and it's just the driver. You have to go buy or have the tools already on hand. Does that make sense? So that's why a lot of these, you'll see them made out of, well, if you live anywhere but around here, they call it aluminium. We call it aluminum. We use aluminum for these a lot because aluminum weighs quite a bit less than steel. Let's put it that way. Okay? So we make it out of aluminum because aluminum's lightweight and can actually be pretty sturdy. Most of us think aluminum, we think what? We think aluminum foil, like we're covering dishes and stuff with, right? And that's it. It's very easy to poke a hole in. Now, we're talking about aluminum, the solid one. So your tooling has to be as lightweight as possible to get and still be able to get the job done. Okay? One of the biggest requirements for a tool is that if it is picking something up or moving something, if power is removed, it can't drop it. Why? Well, because if something's under it, it could very well drop it on somebody's head or foot or itself and just kind of destroy everything under it. So containment is one of the biggest things you have to worry about with these, is that you want it to be able to hold on to whatever it's moving. Does that make sense? And the design should always be simple, because the more complicated you make something, the more easily it what? What do y'all think? The more complicated you make it, the more what? Easily it breaks. Think about that for a minute. Think about something that you've got that's got all this complicated parts and stuff to it. What happens if you, let's say, start really messing with it? You find all those nice little weak points where it just starts breaking apart in your hands, right? Y'all know what I mean? So that is something you have to look to with any design of anything. Now, there are people out there that like to complicate things. To them, I say, why? One of the more interesting complications I have ever seen put to use in the real world. How many of you watch ads for cars and trucks? If you have, you've probably seen the GMC truck commercial where they have the multi-configuration tailgate. Y'all know what I'm talking about? Oh, you can put it up and it can hold things to the bed. Oh, you can pull it down and it's a step. Oh, you can do all this stuff with this. You know, it's got like 10, 15 positions. You know what I look at that and say? Why would you go and change up a tailgate? It was fine the way it was because now you just created something that's going to break. The more complicated you make something, the more easily it breaks, or the more easily something gets damaged and you're toast. So that's why a lot of the times we try and keep tooling simple, not to mention as maintenance. What would you rather work on? Some overly complicated something or other that you have to go in and trace every little thing down and you come into all this maze and puzzle of wires and circuitry? Or would you rather go after something simple that all it takes is, oh, there's a bad wire. Switch it out, done, and you move on with your day? Which one would you rather work with? Just to clarify again, the whole reason the whole thing we call these tools are things like end of arm tooling. You might hear it as EOAT, the abbreviation for it. You might hear it called the end effector. Sometimes used as well. You will often hear the term gripper, but it is not generally used in the correct way. If that makes any sense. A lot of people like to call the end of arm tool a gripper. It is not always a gripper. Right? These guys can do anything you can imagine, not just pick things up and move them. So one of the tops of the power supplies for a tool typically are pneumatics. Now, why pneumatics? What do y'all think? Well, you're on the right track. It's not just so much the air compressor. The whole reason we like to use pneumatics is for a couple of different things. One, most every shop or factory has a pneumatic compressor. It's a very easy thing to run. You can run pipes and tubes anywhere you need to. It's a very flexible system. Two, it's very environmentally friendly because once I'm done using the air, it's still just air. I can release it back to the wild. Okay? So it's a very clean energy source. So pneumatics is one of the top things that we use because it is what it is. Basically, you're pulling in air, you're compressing it, and then you're putting it into the tool. There's really not an easier technology. You have springs. Springs are sometimes used. But for some reason, a lot of people tend to want to use pneumatics whenever they can. Hydraulics. Hydraulics are very interesting because if you ever hit water in a belly flop, what happens? Kind of knocks the air out of you, right? Why? Because water and fluid in general are incompressible. Liquids in general are incompressible. What that means for us is that by pushing liquid into a small place, we can do a lot with a little. Okay? If we need very small cylinders, we need those cylinders to put out a lot of power, we're going to go hydraulic, not pneumatic, because pneumatic, the more power, the bigger the piston, it's not so much more the power you get. So hydraulics are used where size and force are needed. Why don't we want to use hydraulics all the time? Well, because it typically gets a little expensive. Because you're using petroleum-based products just like you would in your car. What's the price of oil these days? Yeah, generally an oil change right now costs you about $100. Most of that is just in oil and your filter. It's not so much in labor because it doesn't take them that long to change it out. But the price of it is mostly the oil. So hydraulic can be kind of expensive to run, not to mention, unlike pneumatics where you can just vent it to air and nobody's going to care, this you have to literally make a return path for it to go back to tank. You have to change the filters periodically, and periodically you're going to have to drain that tank and change out the oil in it, because otherwise, like what happens in your car if you forget to change the oil for a while? Your oil gets super nasty, things start locking up, breaking, and everything becomes gummed up because of all the crud that's in there. For those of you that did not know that. So hydraulics is good because in just sheer power, hydraulics can do a lot. We use them today to bore holes in the earth. We use it to do just about everything. But for smaller, more delicate jobs, you can't really ask for much better with hydraulic. It just gets expensive over time. And then you have electric. Now electric, I won't say it's not used, but it does not generally seem to be the preference. The main preference is pneumatics or hydraulics. Why? Because electricity is, I won't say it's unpredictable, but it can cause trouble, if that makes any sense. If nothing else, think about your light switches and your surge protectors and stuff. Because when you start pulling that plug out, sometimes you get a what? You get a little spark. Well, if you're in a flammable environment, you don't want sparks. All right? Or if you're doing jobs that are really, really dirty, you don't want to have to deal with something like that because that could cause trouble. So, like I said, hydraulics and pneumatics are the ones that are mainly used, especially pneumatics. Pneumatics are the big popular one. Simply because getting it from point A to point B is about like no effort at all. So you have groups of AUT. You have standard grippers, which again, I don't really much like the term gripper, but we'll go with it. You have vacuum devices, magnetic devices, flexible pneumatic devices, and special purpose tools. Okay? So standard grippers are, I don't much like how they are talking about it here because there's a lot of different ways you can make a gripper. The ones we typically think of are like the ones that are on these 4 robots. They're a standard parallel gripper. I can also make a gripper that has 3 prongs if I'm trying to pick up something cylindrical. Or I could bore a hole in a parallel gripper and pick it up that way. It always depends on what your needs are. Whenever you get a robot, you design that tool based on your needs. You don't base it on somebody else's design. You base it on, this is what it's going to be doing. So we have parallel motion. So they remain parallel to each other as they open and close. You have angular grippers that move like scissor blades. And as far as grasping from the inside or the outside, you have to be kind of careful with those. So you have your angular and you have your parallel. Now parallel is again what we typically think of as a gripper. But I can change the configuration of that any way I need it to be so that I can pick up what I've got to pick up. All it takes is a little bit of ingenuity. And then we can also, now the way you pick it up is going to depend upon the product. If the product's outside is, let's say, delicate, okay? If it's easily broken, you might not want to use pneumatics for that because pneumatics is very hard to control the pressure. I mean, exceedingly difficult to try and control an output pressure. Why? Because air does not like to be told what to do sometimes. So sometimes you're going to come down and grip the externals, but if, let's say it's painted, then instead of coming down and messing with the paint on the outside, I might come down on the inside, push it open, and pick it up. Does that make sense? Again, it's all dependent upon the product you're dealing with. Like I said, you don't just have to have a parallel gripper set of 2, you can have a parallel gripper set of 3. In this case, what you do is, well, for this one you could run it only one way, because what it does is whenever you are not applying force to this, it's going to close itself in. Then you put it down inside the product, you trigger it, and it expands itself to fill the space so it picks it up easily. You got the scissor grippers doing the same here. Okay. So servo versus non-servo grippers. With grippers, we typically keep them very low tech. Why? Because the lower tech you keep something, the less you have to fix it. That's the honest to God truth. The lower tech and the simplest you keep a design, the less you got to crawl through it to fix it. So you do have some that have the ability to vary their pressure and have tactile sensors to measure that pressure. But that is not the most common nor the norm. The most common ones are open loop systems. And that grip strength depends completely on the air pressure that is being applied to the system. Most tooling's open loop, again, because it just makes it that much easier to fix it down the line. Not to mention, most objects, I will not say all objects, most objects are fairly sturdy. They're not going to need, excessive pressure. We generally keep the pressure about 60 psi, maybe up to 120 if it's a really heavy object. Most of the time, if it's not a heavy object, we reduce the pressure and we don't have to worry about the gripper breaking it whenever it closes in on it. So some of them do have tactile sensors, but it is not the norm. You have vacuum devices. Vacuum devices are used very frequently as well. Why? because as long as your product is not too heavy, or you can put enough suction cups to it to help you lift it, then they're actually a really good way to pick something up without damaging it. So atmospheric pressure is 14.7 psi at sea level. What does that mean? What does that mean to y'all? Why is it something that we would talk about? Hmm? Mm-hmm. Well, the higher you get on the ground, the less pressure there is. The lower you get into the sea, the more pressure there is. With pneumatics, you have to account for that 14.7 psi difference, because that 14.7, if you go to the ocean, that is the air pressure around you. Okay, basically that's the air pressure that's holding you to Earth. Okay. So vacuum cups, the biggest issue with vacuum is that anything you're picking up has to be what? Has to be flat, right? If you pick anything up that's got a whole lot of bumps and rough surfaces, can you get a vacuum on it? No. It's kind of like if you've ever played with a straw. What's easier to pick up? Something like an ice cube that's got all the bumps and ridges on it, or something flat. So you do have a couple of different ways of doing this. You have the vacuum cup and you've got the vacuum surface. Both can be used pretty frequently, but you do have maximum lifting capacity. And one of the biggest things you have to worry about is, let's say power goes out at the plant. That's going to include all your grippers and all your vacuum tools and everything that's connected to anything electrical. You do not want this thing to just randomly let go of something. I've seen these. The coolest thing I've ever seen a vacuum set do is, I'm going to geek out and be weird here. How many of y'all watch Mythbusters? The last episodes, there was one of them where they picked up a car with a shop vacuum. One of the coolest episodes ever. They created these boxes that were basically giant vacuum cups, and they were able to lift an actual car, engine and all, with nothing but a vacuum cleaner. The pressure was really high. But the second that the vacuum became unplugged, it dropped the car. Yeah, it was quite a bit of car carnage on that particular drop. But that's something you have to be very wary of dealing with vacuums, is because if you remove power and you lose that suction, it's going to drop whatever it's got. One of the most common ways we typically like to use vacuums is on things like glass. Yeah. Because why? Well, if you used a gripper on glass, what do you run the risk of it doing? Not scratching, shattering. Yeah, you run the real risk if you use something like a gripper on a piece of glass and you're not careful with the pressures, you risk that glass shattering everywhere. Not a good way to go. Hmm? Mm-mm. Mm-hmm. Sounds like a giant shop vac. Yep. So vacuums require you have some sort of way to generate said vacuum, and you have to have power generally for anything like that. So that's kind of the big problem with vacuum devices sometimes, is that It's not so much the picking up and moving, it's it doesn't have power anymore, so it might drop what it's got. And if it drops what it's got, that's going to be a mess. And I do mean a mess. Because if it's like something like a glass windshield, and the reason I mentioned the windshield is because that's one that I've actually seen it used for. And it's a very interesting way to use it. But at the same time, you have to look at it and go, okay, well, if that drops it, that's going to be very fun to clean up. So when it comes to vacuum devices, you do want it to have its own little power source, or you want it to have a backup source. That way, if you do lose power to your factory, your vacuum generators don't just immediately let go of all your product and your product's on the floor. Okay. So for this little place, excuse me, let me back up. What they're describing here, and what they're talking about is that, again, we talked about 14.7 being the normal pressure at sea level. That means that when you are at sea level, every surface has 14.7 psi pressing against it. Now, why don't we feel that? Well, because we are used to it. This is what we've literally been working with for eternity. All right? But it also means that that's also not helping you whenever you want to get into your jar of spaghetti sauce. Because whenever, I don't know if any of y'all know anything about canning, but the way you can something is essentially you expand all the air out of it by putting it in boiling water. Then you put a cap on it, and when it cools, it creates a vacuum. Because cold air is what? Cold air kind of is dense, right? So instead of this loose hot air, because hot air expands, cold air retracts, creating that vacuum, which makes it to where the cans will seal. Well, all you're trying to do is create a differential pressure with that. You're trying to release some of the air pressure in it enough that it allows you to pop that top. So what you're doing is shifting things around and allowing for pressure differentials to be created so that, I'll put it to you this way. But that's pretty much it. Sorry, I've got too many different things in my head that are irrelevant. Okay? So when you create a vacuum, that's the whole issue with trying to get it open. Okay, so we use vacuums quite frequently, again, not generally for overly heavy things most of the time, just because if you lose power to the vacuum, you don't want something heavy crashing down on your floor. All right. So here's some different ways to do it. And the configurations come in whatever is necessary for what. What is it you're trying to pick up, right? What is the size and shape of what you're trying to pick up, and how do you need to pick it up? If you're going to use vacuum power, A, you need to make sure your surface is completely, A, clean, and B, flat. Right? You can't have little ridges and bumps all in it. It can't seal around that. Right? But you especially want it clean, because why do we want it clean? So you get good suction to it. Okay? That, and you really want to be careful not to get a bunch of dust into your vacuum generator. That can damage it quite a bit. So We like to use these in fairly clean environments. Magnetic devices, we have two different types. We have the electromagnet and the permanent magnet. The electromagnet is a better, well, I'm going to say this is my opinion. An electromagnet is a better way to go with these because you can use electricity to turn that on and off. Versus a permanent magnet, which you would have to create a contrary electric field in order for it to let go. That or you're going to be scraping it off the magnet, which is not a really great thing. So if you want to think about what an electromagnet is, think about the cranes at something like a junkyard. Those are electromagnets because they use electricity to help pick stuff up, especially heavy metallic objects. Now, that does come as a double-edged sword because if you are the person that's picking up something really heavy and you lose electricity without backup, you're going to be dropping whatever it is. So, some things are good, but they can also have their bad side. Flexible pneumatic devices, they come in a lot of different shapes, sizes, and everything else. It just, what have you got to have it do? We've watched some of the videos that I've shown y'all where you can see multiple different types of end-of-arm tools. Something like this, you could maybe call it a gripper, but it's also basically a palletizer because what it's doing is it's moving that dog food without breaking the bag and it's just setting it down on that pallet. Okay. Here's another way, same thing here. Trying to see exactly what they've done here, but I think they're trying to use some sort of a gripping device, but I can't really tell. What you can see is presence devices here. Not quite sure what they meant to put on there. So robots can do basically anything we ask of them as long as we give them the right tool. And this one's probably since we're talking about pneumatic devices, the way I can see this working is that it sticks itself into the hole of the roll right there and just expands out. Helps it pick up. Okay. All right, so this is talking about pin lifting devices. So again, it works just like a gripper almost, but this is a little bit of a flexibility thing because what you have is a rubber diaphragm wrapped around the inside of this. And just like if you're picking something up with, let's say, a rubber balloon, all it's doing is it's pushing air inside it so that it forces it out or in to help grip something. Does that make sense? And it only lets go when air is not applied. Okay, media not found. What the heck? Well, apparently that's not working today. Okay. So you have robot. This one's got an arc welding tool. You got circular part grippers. But again, I'll just kind of say this with anything to do with a robot's end-of-arm tool. Basically, it's like walking into a hardware store. You can kind of pick whatever tool you need for the right job. But with robots, all you have to do is figure out how to make it. And generally, you're making it from scratch. All right. Any questions, guys?